This is the extension of evaluating limits analytically. So we did in first video, we learned 3 methods, and the fourth method here is functions involving higher powers. For example, limit x approaches to a, or x approaches to 3, x to the 5 minus 243 divided by x minus 3. Factoring this one is a pain. To solve these kind of problems, we have 2 formulas. Limit x approaches to a, x to the power of n minus a to the power of n is that. And if we have the exponents on the top and the bottom, then simply we repeat the process on the top and the bottom and combine, you get that answer. So these are the 2 formulas that you need to memorize. So whenever we have higher order exponent, and if I plug in 3 to the 5th power minus 243 divided by 3 minus 3, that's going to give you 0 over 0, indeterminate. Do not ever forget to plug in first before you go to any method. If it is not indeterminate, we are done. But if it is indeterminate, then we have to do something else. So looking at this, because I have higher powers, I would think of applying the formulas I just learned. I need to see that as that formula by looking at this and this exponent. I would think this must be 3 to the power of 5. If I calculate 3, 9, 27, 81, 243, and that's a correct answer. So once I know the correct setup falls under that formula, now I can use the formula to get the answer to be 5 times 3 to the power of 5 minus 1, 5 times 3 to the power of 4, that gives me 405, 81 times 5. Or you can also leave it like this, that's fine too. Next method is piecewise function. Piecewise function is a function that involves several pieces. For example, f of x equals 3x minus 4x squared plus 5. X is if x is greater than or equals 1, equals x minus 2 plus 5 negative 1 less than or equals x is less than 1, equals x plus 2 if x is less than negative 1. That means based on the number, they want you to take the piece. If x is more than 1, take the first piece. If x is between negative 1 and positive 1, including negative 1, take the second piece. If x is less than negative 1, take the third piece. And if they ask me to find out, so I'm going to show you 3 different limits here. If they ask me to find out limit x approaches to 2 f of x, limit x approaches to 1 f of x, limit x approaches to negative 3 f of x. So for the first piece, where is 2? Is it on the first piece, second piece, third piece, or is it in between? Correct. So 2 is more than 1, so this is in the first piece. So I would simply take the first piece here, which is 3x minus 4x squared plus 5, and just simply plug it in. 6 minus 16 plus 5, that's negative 5. And then for part B, question is asking you to find out limit x approaches to 1. Here 1, I call that as a split because that is where the function got split into 2 different pieces, when it is more than 1 and when it is less than 1. So in this case, I need to find both left and right limits. So I would say limit x approaches to 1 from the left side and limit x approaches to 1 from the right side. If they both are same, I would say a limit exists, otherwise the limit does not. X is less than 1. Here 1 from the left side means we need to take the piece where x is less than 1. If I take that piece, the second piece, I would have function this. If I plug in, I would get 4. Whereas 1 from the right side, I have to take the first piece of the function because that's when x is more than 1. If I plug in, I get this, which is 4. Since both pieces are the same, I would say the limit exists and the common value is 4. If they are different, I would have said that the limit does not exist. So my conclusion for this problem would be this. Complex powers. This is not exactly complex powers, but we have something like this. Limit x approaches to 2, x plus 1 squared minus 9 over x minus 2. Of course, I plug in, I get 2 plus 1 squared minus 9 divided by 2 minus 2, indeterminate. Because it's indeterminate in this case, I have to look at the methods that I learned, I just wrote, and that's one of the methods says that if you have exponents, expand it. What do you mean by expanded? So I FOIL this, x plus 1 times x plus 1, that gives me x squared plus 2x plus 1, and I do that, and then minus 9 divided by x minus 2. Combining like terms gives me negative 8 there, and then factor the top. This function is number 1, that's a rational function, remember? Now it turns out to be number 1, and for rational function, I need to factor this. 2 numbers that multiply to give you 8, and 2 numbers that add to give you 2 would be x plus 4 and x minus 2. See if you can cancel anything. Those 2 cancel out, and plug it into the leftover function, and that gives you the answer 6. We have 3 formulas in trig limits. We need to memorize this. Limit x approaches to 0, sin x over x is 1. So is limit x approaches to 0, tan x over x. Also, this is another formula that we need to remember, that is 0. If I plug in here, it's a 0 over 0. That's not indeterminate. That's 0 over 0. That's indeterminate, so you need to use that formula. And here if I plug in, I get 0 over 0, but it's not 0, it's not 1, it is just a 0. So watch that I did not cancel those two and wrote 1. That's a bad math, but we just have the formula. Somebody proved it, and we are going to use them. So let's see how we can apply this in formula. We're going to do a lot of trig limits of problems in class. I just want you to have an idea before you come to the class. Say I have something like this. Now I want you to notice the problem, the formula that I gave you. What we need to match here is whatever inside the trig should match to this one and this one. We can't change this, but we can manipulate this one and this one. So we need to manipulate those. Here I have 3x inside the trig function, so I need to have 3x outside trig function as well. So what do you mean? So I have sine of 3x. I need to match 3x. I will put 3x underneath because whatever is here, it should be here. So I put 3x over there, times it by 3x to balance the equation, because when I simplify these two, I'm going to get same thing on the top. Divide by whatever I had here, I'm going to write it here. So now, if I cancel them, whatever I wrote in blue, I get the same answer as before, so I don't have to worry about that I changed anything. I did not change anything. Now this becomes sine 3x over 3x, and then we can cancel these two x's here. I get 3 over 4 there. Now this is matching, this is matching. I'm going to multiply both sides by 3 here to match this one as well. So this becomes 3x approaches to 0. 0 times 3 is 0. And then 3 over 4. According to formula, that is 1 times 3 over 4. 3 over 4 would be my answer. Let's see another similar problem here. So here I have sine and tangent both. I'm going to write whatever I have there, sine of 5x, and I need something on the bottom here. What do I need? Good job, I need 5x. I'm going to write 5x. Whenever I multiply the new term in blue, I need to divide that by same term. So I multiplied divided by 5x, and I got those. But I still have tangent 7x on the bottom, so I'm going to write that. So if I have tangent 7x, for the very same reason, I need a 7x here, so I need to multiply. I'm writing this extra, so I need to multiply that so that I can balance the equation. So I'm going to rewrite this equation. You can write a limit as many times as you want. It is just saying that x is approaching to 0. That's all it's saying. It doesn't say anything. If I multiply limit x approaches to 0, both sides by 5, I can get 5x approaches to 0. And I have tangent 7x over 7x here. I can say limit 7x approaches to 0 with the same logic. And I got 5x over 7x here. I could cancel these two. Top one is 1, bottom one is 1. The answer is 5 over 7. Here, do not think that limit over limit cancels out and that is no limit. No, you cannot cancel the limits. Limit is just a statement that says that the value is approaching to whatever the value they are saying. Here in the case, limit x is approaching to 0. It is a statement. It is not a value, so you can't cancel them.